Welcome to the first in a series of NTPEP webinars that are aimed at introducing some of the newer evaluation programs. I'm Bill Reel and I'm with NTPEP. For those of you who may not be familiar with NTPEP, NTPEP stands for the National Transportation Product Evaluation Program. NTPEP is an AASHTO technical service program that can provide savings to the states in the forms of reduced manpower and other resources needed for in-house evaluations. NTPEP can also provide more complete evaluations in cases where states do not have a robust evaluation protocol in place. The way it works, manufacturers submit their products to NTPEP. The products are evaluated following an evaluation protocol that is designed by the appropriate NTPEP technical committee and balloted to the member states. The manufacturer pays the testing fee to NTPEP, and the testing lab works for NTPEP, assuring independent, unbiased evaluations. Results are made available to the member states online through NTPEP Datamine. Today's presentation will describe the NTPEP evaluations of spray-applied pipeliner products. There's going to be a couple of online poll questions, and you'll see a screen to enter your answers. All attendees are muted because this webinar is being recorded for future use, but questions can be submitted by typing them in the comments and questions box. One of the hurdles of starting an evaluation program such as this one is that manufacturers are reluctant often to submit their products and pay the testing fees until they see that states require them to do so. At the same time, states may be reluctant to require NTPEP testing until they see that a number of manufacturers have had their products evaluated by NTPEP. Given the potential benefit to the states, I think it's important that states take the first step to get things started. So what I would like to do is encourage you to all watch this webinar, review the work plan, which describes this evaluation, ask questions, and consider how this program can help you. Assuming that you see the benefits here, then it would be helpful to notify spray-applied pipelining manufacturers of your intent to require NTPEP evaluations for their products. By notifying them of your intent to use this evaluation, it will encourage them to participate and provide the states with a robust, independent evaluation to base their spray-applied pipelining product acceptance on. With that, I'd like to introduce Jeff Sire of Ohio, who is the chair of the Spray-Applied Pipeliner Technical Committee. There you go, Jeff.
A summary of the SAPL TC. It's a trenchless technology utilized to rehab stormwater conveyance conduits. It can be applied to many different conduit shapes, sizes, and/or materials. SAPL can be a structural in nature, or it can be non-structural in our work plan. Did want to point out that the host conduit that we're going to rehab with this technology may require additional repairs prior to the application of an SAPL, and that's not covered under this work plan. Example of that might be we need to fix the invert of a corrugated metal pipe prior to applying this SAPL. The SAPL material may be resinous or cementitious. A resinous material is either a polyurethane, a polyurea, or it could even also be an epoxy. Cementitious material would be a Portland cement or a geopolymer concrete. When a geopolymer concrete is a concrete that doesn't use Portland as the bonding agent, it uses aluminum and silicone. All right, this should get us caught up. Example installations for the cementitious. Got some graphical pictures here. Up in the right-hand corner is an applicator. It's a sled basically that's pulled through, and you can see over here on the left-hand side, you can actually see it where they're getting ready to pull it out of the pipe. So it's pulled through and it spin casts the material on. And the lower right-hand corner, we've got a pipe art shape that was spin cast, so it kind of just shows that it can be used in a variety of different shapes. However, most of the time it's used in round, which is what we see in the lower left-hand corner. And I did want to point out, you can see the invert of this pipe has got a little bit thicker material than what, say, the sides have. You can see the corrugations in the side and you can in the bottom. And that's the perfect example of where we had to come in and repair the bottom of this pipe prior to the spray-applied liners. So I believe it was the same vendor. You used a different material. He put it in the bottom, to fill in the voids, and then he applied his SAPL across the rest of the conduit. And here's an example of a resin-based product. The key difference between a resin and a cementitious product is that this is applied by hand, whereas a cementitious product, in most cases, is going to be applied by that sled, that little spin cast applicator, unless the conduit gets to be of a size that's large enough that the sled wouldn't work, and then they would go to a hand-applied application. And again, we have in this scenario, over on the left-hand side picture, we have the invert. You can see it is kind of flat. Again, this vendor went in and repaired the bottom of the culvert prior to putting the SAPL on. So I wanted to do a quick poll here just to see how many DOTs are using SAPL that you're aware of. You might not even know. I don't. So we've got some options here. And Ryan, are you going to take it from here?
Yep, I sent it out, Jeff. You just don't get it because you're a
Perfect.
presenter. You don't see it. But seems like people are answering right now. We have you might be able to see this numbers too, Jeff, on the right-hand side. Click on poll. You can see the current graph. We have 46% are saying yes, 35% don't know, 11% are a maybe, 8% are a no.
Okay. Well, that's encouraging. Looks like the majority has used it, and they are aware of it at least. Great. Okay. I'm going to move on to the next slide. Okay, so here's a list of current technical committee members for the SAPL, and this is also available on the NTPEP webpage. We have a good representation of DOTs, and we have a good representation of vendors in here as well. And we have vendors from both cementitious products, and we also have them from resin-based products, but the large part of them are cementitious vendors because that's really the product that's being utilized the most at the moment. All right, so the purpose of this work plan, really of a lot of the work plans through NTPEP, is to provide material testing for the vendors. In our case, it's the SAPL vendors. And that information gives DOTs, confidence that the tests were performed in a certain standard. The coupons might have been, are exactly the same size. A lot of times when vendors approach the DOTs with their testing material, we're all a little bit skeptical of it because we know that minute differences in how the test is performed, you can get varying different results that could be widely different. And, a lot of the vendors will latch on to that and promote that as something special about their products. So the beauty of NTPEP is that it levels the whole playing field. This information is provided to DOTs to give us confidence in the testing results, and it also is great for the vendors because now they have an avenue to go to the DOTs and say, hey, our product was tested by NTPEP, which is pretty well respected. Our work plan also does an additional component than a lot of other work plans through NTPEP. We do some structural testing as well. Of course, it's under laboratory conditions, but it still gives you some confidence that, yes, the product can provide a structural component, because a lot of vendors will claim they can do this, but they really have nothing to support that. So the work plan can be found here on this link. And I will click on this, and it will show up on my other screen over here. This is where you land when you hit that link. This is just basically the whole work plan. That's the title sheet. I'm not going to go through the work plan in detail, but it does include a lot of AASHTO and ASTM. Where we could, we always tried to go with an AASHTO spec since we are AASHTO. You can go through here and read this at your leisure, but it is pretty inclusive. There's lots of information in here. Some of it's boilerplate information that's pretty common to all the NTPEP plans, but then there's also some unique stuff just for the SAPL. Okay.
Hey, Jeff, we have a question.
Yes, sir.
I'd like to take the question now. The question is, can the pipe have moisture in the bottom when the SAPL is applied?
Great question. So it really depends on the material that's being applied. In most cases, the answer is no, it cannot have moisture. It needs to be fairly dry. Some vendors will tell you that they can apply with some moisture. Other ones will tell you that it has to be completely dry. So it kind of depends on the vendor and the product. Thanks for that, Ryan. Keep an eye out for those questions because I'm not looking for those. Okay. Yeah, we already covered this. The only other thing I wanted to tell the group is that this work plan, it took several iterations over the course of a couple of years really to get to where we're at today. And it was both collaborative between the DOTs that were involved and or the vendors. So we feel like we have a pretty good plan. The vendors have a pretty good handle on their product themselves, and the DOTs have a pretty good handle on what their expectations are, which makes a good marriage to come up with a work plan. So just summarizing the SAPL TC a little bit further, one thing I wanted to bring up that kind of reared its head early in our development was NTPEP in general does not support product development. And when vendors come to NTPEP, the expectation is that the product is ready for its final testing. All the development has been done. It's going to be used at the DOTs as it's presented through the program. So I just wanted to point that out for any vendors that are online. NTPEP also does not interpret testing results. We've seen vendors get their testing done through the SAPL, and they'll come out and make statements that says AASHTO approved, NTPEP approved. I just wanted to make sure everyone's aware that there is no approval process, that NTPEP does not approve the results. NTPEP clearly does the testing and records the results. That's all that they do. All the interpretation of the testing results will be left up to each individual DOT.
Hey, Jeff, we got another question here.
Yeah.
Cut in real quick. This person would like to know, how long on average do you need to keep the pipe from getting water in it after the application is applied?
Oh, again, that depends on the material, but it's, the resin-based materials, it cures pretty quickly. We're talking minutes it's cured. Not fully cured, but it's cured enough. The cementitious products takes a little bit longer, and I don't have a time frame for you. That again would probably be up to the individual vendor and their mix and how they do it, and it might even depend on the length of the pipe, because they have to pump this material from where they're mixing it down into where they're applying it, so it might change the mix slightly a little bit. But yeah, I mean, we have had products here in Ohio, cementitious based, that the water was let in too soon, and it did take the bottom out, and we had to go back and do it again. So yeah, it's a good question. All right, so all the testing that's currently laid out in the work plan through NTPEP is done with TEC services, and they're located in Lawrenceville, Georgia, which is a suburb of Atlanta, Georgia. They're doing all the testing for us at the moment. And the testing data that they do, once they complete their tests, they'll push the data up to NTPEP Datamine, which was already mentioned by Bill early on, and that allows access to all the DOTs to go to after it's been reviewed by the lead state, which in this case happens to be Ohio. And I've got a link here for NTPEP, and I'll click on this. So this is what NTPEP Datamine looks like when you first go into it. This is the public-facing web page. If you had a login, you would go up here to the login, and you would log in with your credentials. So there's a variety of different tabs up here. We're going to be listed under the Maintenance tab, and if you go to Spray Applied Liners, you'll see it right here. And click on that. And this takes you to the generic information. These are all the vendors that are currently in the program. It gives you a quick status of where they're at in the program. And you can dive a little bit deeper into their information by clicking on one of these. Let's see, let's select AW Cook. Now you can't actually get to the data unless you log in, but you can quickly see, there's a manufacturer information. You can go to test data. And over here, it says restricted because we're not logged in. If you're logged in, you'll be able to access the data, but just wanted to show you how there's different tabs. So there's a tab for structural data. There's a tab for 28-day data. This is the physical data. And then there's freeze-thaw data. And we have another blank here for additional documentation. So if you were to log into this, you would go up to this, punch in your email address, your password, and log in. And for those of you who do not have a login, who are interested in getting on, you can go over here to the Register Now button, and it'll take you to this, and you can plug in your email address and walk through the process. I'm not going to do that, but basically, if you have a DOT email and you're from a DOT, they will give you access to all the data. Then you can see all the data that all the vendors have. If you're a vendor, obviously, you can only have access to your own data. So I want to just kind of show that. I think that's important, not only for our program, but also for all the other ones that are in NTPEP. All right, we already talked about that. We talked about all this. Okay. And I put this slide in here just in case my internet wasn't working, because you just never know. All right, so the physical material testing, this also is referred to, we call it as a 28-day testing, because that's the curing time frame that it takes for the cementitious material. It takes 28 days before they'll do any testing. So they'll make their coupons to whatever size is required by the ASTM or AASHTO test, wait 28 days of curing, and then they'll go do the test. For the vendor, for the resinous products, as we indicated before, the curing time is pretty quick. It's literally minutes in some cases where this stuff will cure. It's really up to the vendor itself. Most of the time it's pretty quick. They can apply it and then just wait like a day and then go do the testing. So now this physical test for both cementitious and resin is required every 4 years. That's a frequency that we agreed to with the vendors and the DOTs, and that's in our work plan. Now the structural testing, this is a little bit unique to our work plan because we had to kind of put our heads together and think about how we were going to test this material for a structural capacity within a lab environment. So we came up with a couple different methods. This is performed initially through the submission. Once the product is submitted, they don't have to come back and re-perform this test because it is an expensive test. So we said, okay, you only have to do this one time when you initially submit, or if you modify your formulation. If you modify your formulation, of course, you got to go through all your physical tests again, then you have to come back and do your structural tests. So we have two different methods. We have one called Method A and one called Method B. Method A is simply a deload test where we take a 48-inch concrete pipe, reinforced concrete pipe, and we will crack it in the deload test initially, just a bare pipe, and then we'll have the vendor come in and apply their liner in different thicknesses, and then we'll let it cure, and then we'll come back and we'll do another load test again, and that will show us if we have an increase in capacity or not. And Method B is what we call the parallel plate test. It's a test where it's generally applied in a more flexible material, and we apply that in a 36-inch and a 48-inch removable form. That's what we deemed in the work plan, which really we were thinking cardboard sonotubes when we were thinking this through. But they would apply their liner material in there. We let it cure, and then we do the parallel plate test, which basically deforms the pipe vertically by at least 20%. And then we see if there's any deformations or issues during that deflection. To date, Method A has been the only test that vendors have chosen. And Method B, no one has chosen that yet who has submitted through our program. So I won't talk a whole lot about B, but I'll dive in a little bit more about the Method A. So the method A, again, you're looking at a 48-inch reinforced concrete pipe. The first thing we're going to do on an annual basis, according to the work plan, is we get a baseline deload for that pipe, and then we get a baseline ultimate load for that pipe. So the work plan says you need to go out and get 3 samples of pipe from a vendor that's commercially available deload. So it could be a 1,000 deload pipe, 48-inch, whatever's available near the testing lab. And they come back and they'll perform the actual deload test, and then they'll keep loading it until they get to the ultimate load test. And the ultimate load test is where you no longer can carry a load, essentially. And that establishes our annual baseline deload and ultimate averages. So we know what's coming from that vendor should be around that ballpark figure when we are going to perform this for our spray applied liners. So when we get into this for each of our SAPL liner vendors, we'll go out and get 6 of these 48-inch reinforced concrete pipes from the same supplier who gave us the pipe for the baseline test, and we'll get the same deload designation, and then we'll put that in the load frame, and then we'll load it up and we'll generate the 0.01 crack. So that's the deload test. Once we get that crack, we'll take it out of the load frame, and then the SAPL vendor will come in and he will apply his repair to the cracked pipe. He'll do this for multiple different thicknesses. We have a 1/2 inch, a 1 inch, or a 1.5 for anything that's cementitious. For a resin-based liner, we have 0.25, 0.75, and 1 inch thickness. And they'll have to do this to multiple pipes, hence we have 6. So we have 2 pipes for each of these thicknesses. So he'll apply that thickness, he'll let it cure, and then we'll put it in this deload machine, and then we'll basically test it to deload. And the important thing, the deload this time for the 0.01 crack is going to be in the liner itself. It's not going to be in the pipe anymore because the liner is now carrying that load. And once we get to that, we're going to continue loading until we get to the ultimate load, which again is when that pipe with the liner can no longer carry a load. And we record all that information, and that's what's reported through Datamine.
Hey, Jeff, we got 2 questions. If it's a good stop the pause here and go for those questions.
Perfect.
All right. They're not specifically deload, but they're with the testing. So the first question we have is, does the work plan include any chemical tests that evaluate the environmental impact of the product, such as leaching?
Does not. Only thing it would have is a durability type test, and that's it. There's nothing for leaching at all. No.
Second question we got here. Are the vendors required to submit, are the vendors required to resubmit for IR to see if they've changed their formula?
That is not in the work plan. So no, they are not required to do that in the work plan.
Thanks, Jeff.
That's it? Okay.
Those are the only 2.
Right, keep the questions coming. This is good. Okay, so method B, I'm not going to go into a lot of detail about this, but we do have a whole host of pipes again. We have 8 samples at this point, and these are the forms, i.e. the sono tubes, in the 2 different thicknesses, or 2 different sizes, of 36 and 48, and we have 3 different thicknesses. We have 0.25, 0.5, and 0.75. Again, we have 2 of each of these that we're going to test. And like I mentioned before, nobody has chosen this test yet, and it really comes down to how your SAPL liner is going to fail. And to date, the liners that have submitted, their failure point is going to be cracking. It's going to be more of a brittle type failure. And this test was put in when we developed the work plan because we didn't know at the time if there were going to be any folks that had more of a flexible type material that would fail in, say, buckling. But to date, we have nobody who has submitted on that. Okay. I'm going to do another quick poll here and going to ask some questions here. Brian, you want to take it on your end?
Yep, I just launched the poll, so we'll see what the results here are. So we're about 50% that voted Jeff. We'll wait a little longer till we get closer to the whole group. Then I'll run through all the numbers. All right, so we're at about 75% of the people voted. So we'll run through these numbers. The largest group here, 53%, says the roadblock is lack of DOT specifications.
Okay.
Then at 40%, we have unaware or unfamiliar with SAPL technologies. At 33%, we have accepted structural design methodology. At 19%, available vendors, and at 5%, available funding.
Okay. Okay. Well, funding's not an issue. I like that. Okay. So yeah, lack of DOT specifications. That's interesting. I wasn't expecting that to be the number one, but okay. Well, I mean, for the DOTs that are out there, feel free to reach out to myself or Brian Carmody in New York after this phone call, and we can talk about DOT specifications. Brian's got a little bit different spin on it than what you're going to get from me, but it's probably good that you hear from both sides. But we could probably help you vet through some DOT specifications. And as far as the acceptable structural design methodology, we're going to dive into that in the next couple of slides. Okay. All right, that was definitely a good segue into this. So we're kind of shifting gears here a little bit, and we're going to talk about this active research project that's going on right now, and it's a pooled fund research project. And there's a link here that would take you to the write-up about the research project and what it entails. Ohio, again, is the lead state in this. And I will say that the idea for the pooled fund research really came from the NTPEP SAPL technical committee. As we sat around and we were writing the work plan and thinking through how we're going to do this, we kind of recognized that, there's no standard way to design these. There's no standard AASHTO way. And if you talk to the vendors, they all seem to have their own different way of designing things. Structurally, and in some cases they're the same, in some cases there's a hybrid, some cases they're not. So this pooled fund research project has been active for about a year and a half, and it's about midway done. So the goal here is to develop structural design methodology for spray applied liners. I thought it was a good thing to talk about since we're talking about that technology. So there's 7 DOTs, and there's the 7 that are listed. University of Texas in Arlington has the research project. The PI is Dr. Najafi down there. And here's just a list of the research tasks that we gave them. And he has a pretty conglomerate team. He has some consultants on board. He's got some university folks. But the project was supposed to be wrapping up this December of 2019. However, it got pushed out, as most research projects do. It got pushed out another year and got some additional funding. So we're looking at a date of December 2020 before we have anything report-wise on this. So as part of the pooled fund research project, the physical testing, or the 28-day testing, if we're talking about a cementitious product, came up, and we really thought, okay, we've got this great SAPL Workplan put together through NTPEP. It's got all these physical tests on it. So either A, the university can take the tests out of there and they can perform them on their own, or we could have the vendors go through NTPEP. And the latter was chosen, and that's mainly because the vendors were concerned about a university performing the test. Not that they couldn't do it, they just thought, you know, let's go with a lab that's familiar with a lot of these tests, and we feel confident that our results are going to be good. So any vendors that were going to participate in this research project were required to go through the NTPEP program, essentially. Currently, soil box testing is being performed, and here's some pictures of them loading the pipes, and they're looking at two different shapes. They're looking at a pipe arch shape, and they're looking at a round shape. The round shape is a 60-inch size. It's got 12 gauge. The corrugation size is 2 2/3 by half. The pipe arch shape is a 71 by 47, and again, it's the similar corrugations. One thing that's unique about this pipe is that we had a good discussion on, you know, how we wanted to handle the invert of these pipes, because we're trying to really focus on what the liner is providing strength-wise. So they fabricated this bottom here. Basically, it can come out. So basically, it's bolted. You see these bolts patterns here. We're looking at the bottom side. So once it's put into the ground and installed, that bottom can be unbolted and the plate can be removed before the thing is spray applied. So it's somewhat unique. The control pipes are being tested right now in July. It got pushed back a couple weeks. Basically, the researcher, we really were shooting for an 85% compaction in the backfill, and he did a great job installing the pipe, and he ended up with like a 95% compaction. And, you know, we collectively thought, you know, we really wanted to shoot for that 85 to give it a low strength backfill to try to, again, throw more load into that liner that we're putting in there. So the control pipes are going in now. They're getting tested this month. It's probably getting loaded this week, actually. After that is completed, we're going to throw in another set of pipes, and we're going to start with a resin-based product. And the reason why we did the resin-based product first was mainly because of the curing time. You can apply this, it'll cure a day or so, then they can go immediately load the pipe. With the cementitious product, again, we have to go and wait 28 days after it's applied for it to get its full strength before we can actually do the load testing. So we're shooting for July, probably into August at this point for the resin-based product, and then the cementitious will be later in the fall. And here's some pictures of the guys, the unfortunate grad students that are out there shoveling sand into the soil box. And again, we were shooting for 85% compacted. The invert's going to be removed. You can kind of see the graphics here of how the load pattern is going to show up and how it relates to the soil box itself. The load influence will not go into the walls here. It kind of goes down. And we'll see the bottom down here. This is the invert that's going to be detached, essentially, here and here. And for this research, we're going to test a cementitious SAPL and also a resin SAPL. And we're going to do different thicknesses. These are slightly different than what's in the work plan through NTPEP. But we landed on a 1/2 inch, a 1 inch, and a 2 inch for cementitious. The most common thickness that we're seeing across the board is about a 1.5 to 2 inch. I've seen a lot of cementitious vendors come in with calculations saying that it would work with, say, a 1 inch or even less than a 1 inch. So it's kind of why we bracketed around those numbers. Resin-based material is a little bit different in its physical properties, so it requires a thinner application, and that's a 0.25, 0.5, and a 1. And that's really all I got. I didn't want to dive into a lot of the research since this is a NTPEP presentation about the work plan. I just wanted to kind of, anybody who's got an interest in that can again contact myself or Brian. Brian's also involved with that research project, and we can talk through more information on that. So I guess I'll open it up to any questions that you've got. I've got my contact information here on this slide, Brian's contact information, and then Ryan's information is also on there.
No questions yet, Jeff. We'll give it another 30 seconds here.
Okay.
I guess one of the questions is if we can get a copy of the presentation, and that answer is yes. So we're going to put the recording on the website, and we'll also post the presentation that Jeff and Bill put together, and we'll post that to the website as well so you can download it. We'll send an email out to where it's located to everyone who attended once we get it posted on the website.
Yeah, perfect. Perfect. So again, if questions come up, while you're looking at the presentation, or maybe you think of something at the conclusion of this, by all means, reach out, via email or phone call me, whatever. Brian also could call. And, so we don't have many questions. I guess I will land on this slide. This is just a promotion of additional webinars for additional products through NTPEP. There are dates on there and times. I think if we don't have any more questions, I think we're done. I definitely appreciate the attendance. We had some great attendance. We had some great questions, and I would encourage folks to come back to the other webinars for these other products. These are great products as well.
Thank you, Jeff. Thank you, everyone. This is the end of the webinar, so have a great rest of your week and weekend. Thank you.
Thank you. All right, bye.